All right, respiratory system. So the respiratory system, okay, let's see. We are going to talk about physiology. Obviously, we've done this for the other systems as well. So physiology, what is the respiratory system used for in our bodies? Anatomy, what are the parts, diseases and disorders, diagnostics, how to find out if something's wrong, treatments, and careers. All right, page 1 is the physiology. So what does the respiratory system do? The respiratory system is also called the pulmonary system, and you'll see that's actually the title of your notes. These notes are on the website in case you lose them. The pulmonary system, and it is responsible for bringing oxygen to the cells and for taking carbon dioxide away from the cells. So we talked a little bit about this in the function of the blood and that kind of thing to exchange oxygen and carbon dioxide. And the respiratory system takes in oxygen from the environment and expels when you breathe out. So a large part of that is carbon dioxide. The pulmonary system is divided into two parts, the upper respiratory system and the lower respiratory system. When you breathe in, it's called inhalation or inspiration, or to inhale. And when you breathe out, it's called exhalation, expiration, or to exhale. All right, so taking air in is inhale, to get rid of it is to exhale. All right, what is the anatomy of the respiratory system? The upper respiratory system, this is composed of the organs in the head that help you breathe. These organs also help with the digestive system and the sensory system and the immune system as well. So you do not have this little diagram here, but there are, I'll zoom in just a little bit here. So your sinus is a cavity kind of up above your nose there. And if you get a cold or something, if you get sinuses are plugged, you can kind of feel pressure up there. Nasal cavity, okay, here's your nose, nasal cavity. Your upper roof of your mouth, kind of the hard palate there, soft palate, roof of your mouth. Obviously, air comes in your mouth and it goes down into your lungs, and we'll talk a little bit more about these parts as we move through the notes. All right, the upper respiratory system, the nose. The nose has two nostrils that bring air into the sinuses where it is warmed up. Nose hairs and smaller hairs called cilia help to filter out dust, pathogens, etc. before heading down into the lungs. So your nose hairs actually play an important role in keeping you healthy. They protect from dust particles and also germs. Your mucus catches different germs and dust particles, so that doesn't go down into your lungs. Because if you inhale something into your lungs, you start to cough and spit, and you know that's not very good. So it helps if that gets filtered out just a little bit. All right, the upper respiratory system has three parts. The pharynx, okay, has three parts. That's kind of your throat, where the air kind of comes after your mouth, kind of down to your throat, between that and your lungs. The nasopharynx, above the soft palate at the back of the nose, contains the adenoids called your tonsils. So if you open up your mouth real wide and you look to the back of the throat there, the adenoids or the tonsils would be like on either side of your, kind of where your throat is there. You can just see them peeking out in your, in the very back of your mouth there. Okay. The oropharynx is at the very back of the throat, and it triggers the swallowing reflex when pressure is put on it. Okay. So in the diagram here, the nasopharynx is kind of above there. So it's actually above the palate, connecting your sinuses in your throat. There's actually a bit of a connection there. I think that connects the sinus there. The upper nasal cavity, anyways, your nose. Oropharynx is the very back of your throat there. The laryngopharynx is the part of the throat that divides into two paths, one for food and one for liquids, that goes to the esophagus. The other, for air, goes to the trachea. So you guys realize, obviously, you breathe and you eat through the same passage. It does split. One path goes to your stomach, one path goes to your lungs, unless you inhale your food and start to choke and something's gone down the wrong pipe. You heard that expression before? Down the wrong pipe? Yeah, that's when food goes down towards your lungs, not good. And of course you cough and the pressure kind of pushes things back up and back out. That's why you cough. And if something gets lodged in there and it's not easily pushed out by air pressure, that's when you start to choke. That's choking. Okay?
Does it go to the lungs?
Well, usually doesn't, like if you inhale some food and start to choke, it doesn't usually get all the way down to your lungs in there, no. It just kind of gets stuck somewhere in between. Yeah.
Let's do that right now.
Sorry?
I cough it out?
Yeah, so if you swallow something, like if you're eating peas or something, right, and you're talking and laughing and telling a joke or something, and you like accidentally inhale a pea, it doesn't go all the way down to the bottom of your lungs there. It usually gets it gets stopped in the windpipe, or that goes to your lungs. So it just kind of gets stopped in there. And then there's quite a gag reflex, and you notice and you really feel uncomfortable. And then you cough, and it's your lungs kind of like squeezing and putting pressure on the upper part of your windpipe there. Aaron? Yeah, you have something caught in your windpipe or what? Not quite. Okay, can you go quickly? Hey.
Is it possible for something solid like that to go into the lungs?
I don't know. I think the passages get pretty small. It's tricky to have something go all the way down into your lungs, but yeah, it's possible. Yeah, for sure. Hello? Yeah. Like these ones for sure. I think probably the other ones, the back one you can keep on. It's fine. Whatever. Yeah, does that help there? If you put them all off, open up the blinds there so there's more natural light coming in. That's fine. All right, let's keep moving on. Just open up the blinds part there. Okay, this is my favorite word, epiglottis. It's not my favorite word, but it's a fun word. The epiglottis, this is actually really important. This is a flap at the back of your throat. It folds to cover your trachea when you swallow to keep food heading to the esophagus. So the epiglottis is a little skin flap that kind of flaps over when you swallow there instead of inhaling things. Whoops, let's see. I'm trying to zoom in here. Hang on for a second. Okay, so when you inhale, here's your mouth here. When you inhale, this is the epiglottis right here. It kind of flops over so that food and stuff goes down to your stomach and only air gets let in there. These are your vocal cords. Boys, no talking please. If you have a question, raise your hand. These are your vocal cords, so this is where the air goes to your lungs. So you have a little flap that kind of like opens and closes. Doesn't let food and stuff go down into your lungs. Yeah?
Isn't it sometimes like if like someone like chokes and stuff and they can't get it out, don't they have to like cut open like a little part?
Well, not necessarily from choking, no. It depends. If the like cutting a hole in your throat, that's pretty serious. If something has happened that like your windpipe is totally mashed and collapsed in a car accident or something, or if somebody gets run over, or, then yeah, to get air into the lungs, if this structure is collapsed, then there might be like a tracheotomy would be accessing air into the lungs from down below where the vocal cords and that is. So yeah, that's not. If you're choking, you don't slice a hole in your neck there, but yeah, don't do that. Oh, look, you're choking. Okay, let me get my knife. I'll stab you in the throat so we can get that out. Now, do this. Try and, okay. The little J stroke there, right? The little, yeah. If you can't get it out, then you die, I guess. Yeah. Usually you can, if it's food or something like that you've got in there, it's not like it's wedged in there that you're gonna need to cut yourself open to get it out. It's usually just like your lungs can produce a lot of pressure. So when you cough and your lungs contract, that's a lot of pressure. So, yeah, sometimes you need help. Like that's why, like the Heimlich maneuver. I don't think we can call it the Heimlich anymore. I'm not sure what you call it, but where you put your fist, right, kind of your thumb, just underneath the rib cage there, and then you reach around a person and you just kind of like thrust in a J stroke up like this, and that compresses their diaphragm and their lungs, and it causes a big pressure, and that usually is enough to eject whatever it is that was in there. Okay, so your epiglottis. Now, I often remark to my family when I choke a lot on food and drink and stuff, and my daughter over there, so you see, you're laughing at me. I often say to my family, I have a faulty epiglottis, just leave me alone. So if you choke easily, you might too have a faulty epiglottis. Maybe we can form some kind of support club. Okay. The faulty epiglottis support group. What's that? FESG. Anybody wants to join the FESG? Just come talk to me. I'll be the president of the FESG. All right. So the larynx, larynx. Okay, this is also called the voice box. It has a couple of thick cords that cross the flow of air that vibrate as air goes across them to produce sound. The thicker the cord, the deeper the sound. That's why men often have lower voices than women. One of the reasons, you have thicker vocal cords, and this structure here provides some deeper sounds. They are attached to muscles which can tighten and relax to change the pitch. So literally, if you think about tight strings on a guitar or something, if you think about those, that's kind of like how your voice box works. Air passes through, and your vocal cords vibrate, and when they get thin and stretched, then your pitch goes higher because there's a smaller space for the air to pass through, and then when they relax, there's more space. So that's how you vary your pitch when you talk or sing, or if you're like woo, that's your vocal cords kind of tightening. Whatever that is, right? Go down low. You're just loosening your vocal cords while you're passing air through. Go ahead and give it a try. Everybody wants to try that now. Go ahead and give it a try. Okay. All right. Just get it out. Get it out. Okay. All right. All right. So yeah, I'm sure we'll watch some videos. We'll watch some videos of vocal cords. I've seen a few, and yeah, it depends on how your stomach is. If you have a weak stomach or not, it's gonna get a little like fleshy, but it's pretty cool how they work. So maybe we'll take a look at that here soon. Okay, did you get all the blanks there? Yeah, voice box deeper, no problem. All right, the trachea. This is a tube that takes air to the lungs. It must be kept open no matter what the position of the body is. To hold it open, it has cartilage rings in the lining of the trachea to hold it open. Amazing design feature, kind of like a stiff, like a support, and it only collapses, after an accident or some trauma. So it's meant to stay open the whole time, so you can breathe even while you're laying down or whatever when you're sleeping. So cartilage rings that keep that open. It also has cilia. So cilia are tiny little hairs that continually brush mucus and debris up and out of the lungs. So when you get sick and you have a sniffly nose, or you're blowing your nose a lot, you're coughing up phlegm, your body is producing more mucus in order to bring more of the germs and the violating particles up out of your lungs. And so your body says, oh, we're not feeling well, we need to eject all those germs, so you produce more mucus and phlegm and all sorts of stuff. So that the whole point is that you blow your nose and then you cough it out and you try and get rid of all this stuff, okay? So it branches to the left and right tubes called bronchi. So these big tubes here are called bronchi, okay? So the larynx, your voice box, the trachea, and then the bronchi goes to each part of each lung there. Was there a question back there? Somebody?
I'm going to ask, what if you don't swallow it back in?
Swallow what back in? The what?
The thing that comes out.
Are we still talking about choking now? We're talking about choking? The phlegm?
Yeah, that's
Okay, so if you swallow the phlegm back in, well, then it goes to your stomach. You haven't gotten rid of the germs, although your stomach acid's pretty strong, so you kind of want to eject it right out if possible, but if you swallow it, it goes to your stomach, and the stomach acid's pretty strong and corrosive. So still have the germs in you, but better than being in your windpipe, I guess, or your lungs. Okay, you girls okay over there? Yeah? Okay. All right. It looks like you're dying of laughter. Okay, the lower respiratory system, let's talk about that. This is composed of the lower part of the trachea, the lungs, the ribs, and the diaphragm. Interesting that the ribs, hey, are part of the respiratory system. Let's talk a little bit more about that. So, the upper and the lower. Okay, so the lower part of the trachea, once the trachea branches into the bronchi, it's considered part of the lower system now. It then continues to branch into smaller and smaller airways called bronchioles. Bronchioles. So you don't see them in that diagram so much. Okay, so your lungs. Okay, so I guess you can kind of see, here's your trachea, right here. And then the bronchi. And it branches into bronchioles, just like the branches of a tree, almost. It gets to be more and more. So the lungs, you have right and left lung, but they're not equal in size. The left lung has only 2 lobes, and the right has 3. Oh, did you know that? The left lung is smaller since the apex of the heart protrudes into the space where the 3rd lobe could be. So literally to make a little space for your heart, on the left side, there's only 2 lobes. So it's a little bit smaller. Interesting. The bronchioles end in tiny air sacs inside the lungs where the oxygen enters the blood and the carbon dioxide leaves it. So the very thin interface between the air, the oxygen in your air, and the blood, okay, that oxygen carbon dioxide exchange, which is amazing if you think about that, happens in our lungs in these tiny little air sacs where the walls of those little air sacs are so thin that literally you have gas passing through those walls. Oxygen coming in, carbon dioxide going out. It's amazing, amazing system. All right, alveoli, alveoli. The alveoli are tiny air sacs, I just mentioned, made of very thin membranes surrounded by capillaries. We talked about capillaries in the blood unit, right? The oxygen diffuses into the capillaries before they join back into the pulmonary veins that take the oxygen-rich blood back to the heart. So, once again, air comes into your lungs. The oxygen diffuses into the capillaries in the alveoli, and then they go back into the blood. And so you then have oxygenated blood that's passing by there, picking up all the oxygen. This diagram, so the bronchiole here, okay, it ends in the alveoli, and the oxygen then kind of gets passed through there and then back into the artery that goes back to the heart. And yeah, the vein is what takes deoxygenated blood into there and gives off the carbon dioxide. The arteries take the oxygen-rich blood back to the heart.
Wait,
It's backwards.
no, it's
Because
backward.
It's the pulmonary system.
It's a pulmonary system.
The pulmonary arteries are the only arteries that carry deoxygenated blood.
So the artery, okay, so the pulmonary artery goes into the lungs.
Nah, it's the oxygen.
Because arteries always carry blood away from the heart. And so in this one, they're carrying
Yeah.
Yeah.
to get the oxygen.
Okay, let's just.
And then the veins carry them back to the heart.
Yeah. What did I say? Didn't I say that?
Yeah.
You said the other way around.
Arteries have the oxygen-rich
No.
blood.
Except, yeah.
So oxygen-rich blood. Arteries take the blood away from the heart.
Yeah.
Pulmonary. Okay, so the pulmonary artery goes into the lungs.
And the gas oxygen rich.
And then the veins.
Blood.
And then the pulmonary veins take it back to the heart.
Pulmonary.
Okay. All right. bottom line is oxygen is exchanged and carbon dioxide is given off. Oxygen is taken in. Okay? Yeah, so the vein in the pulmonary, in the lung, the vein takes the oxygen-rich, right, blood back to the heart. So it's going back to the heart.
Yeah. Vein transport.
And the artery is,
Back to.
yeah, arteries, okay. Anyways, there's exchange that happened. Maybe we'll come across that a little more detail later in the notes. All right, let's take a look at the ribs are next. Ribs are next. Make that a little bit bigger. Okay, ribs are bones that protect the lungs from getting punctured. Yeah, it's a major protection for us there. They also help create the airtight cavity called the thoracic cavity that expands to cause inhalation and that contracts to cause exhalation. So inside your lungs, when the cavity expands, it pulls air in from the outside, and when the cavity contracts, it pushes air back out. The ribs contain an inner membrane called the pleural membrane. Pleural kind of has to do with air, lungs. The pleural membrane, that's very, very slippery. This membrane has a thin layer of fluid on it that reduces the friction against the lungs, so they don't get friction burns as you breathe. Kind of cool there. So there's a little bit of a lubricative membrane there. Okay. Okay, the diaphragm. This is a sheet of muscle that goes across the torso under the lungs. So your diaphragm is up here. When it contracts and pulls flat, this increases internal volume of the thoracic cavity, pulling in air. So when this tightens, it sort of pulls everything down and expands the cavity. And then when it loosens, it causes a shrinkage of that cavity and air gets expelled. So when it contracts, it pulls flat and increases the internal volume. When it relaxes, it goes back to its regular dome-like shape. The thoracic cavity shrinks and pushes air out. That's when you exhale. So your diaphragm under there helps your lungs to expand and contract, and in, out, in, out. Okay. Humming. Maybe we could humming. Whoever's humming. Thank you. Question? Chris, you have a question?
It's really hard to hear this point. This because I have heard this just right here.
You have a what right there?
Like I was stabbed by something not through, but it hit.
Oh yeah.
Really hard.
It hurt your diaphragm.
What?
Your diaphragm? Like
Yeah.
injured your diaphragm? Oh really? So make it hard to breathe for you then?
Well,
Painful
whenever
something?
you need to breathe rapidly, it will hurt.
Oh okay. Oh is that right? Yeah.
That was interesting.
Okay. Yeah. Interesting. All right. 5.3 diseases and disorders. Okay. So let's take a look. Since the pulmonary system is one of the main ways to enter the body, it has many different kinds of infections that can be caused by pathogens. We will just discuss some of the more common things that can go wrong. Yeah, obviously it's a main entry point for germs outside. The most common thing that can happen is that a virus can infect the membrane linings of the upper airway. This is called a URI, upper respiratory infection. This can be mild in nature, which is really the common cold, or it can be more serious in nature, like COVID or SARS or something like that. Symptoms include sneezing, watering eyes, sore throat, cough, congestion, fatigue, and headaches. So a relatively minor infection of the upper membrane linings of the upper airway. That's a common cold, upper respiratory infection. And of course, there's varying degrees of those kind of infections that cause more problems. Some URI can migrate into the internal respiratory system, at which point they become a chest infection. Depending on how it progresses, this can become a number of different disorders. Severe virus strains can do this. Common colds typically do not, although they can in very rare conditions. So if you have a cold, it's really just kind of like from here up, right? It's your sinuses, it's your throat, sore throat. If it starts to go down into your chest, you get a chest cold. it just becomes a little bit, the infection starts to drop a little bit into your chest. And you can kind of, your cough changes, you know, how you're feeling really run down. You maybe cough some stuff up because your lungs are producing more mucus to fight it off, that kind of thing. Okay, influenza or the flu. Influenza is similar to URI except that it often will also affect the digestive system, causing nausea, upset stomach as well. Yeah, fever, vomiting, that kind of thing also going along with that, fever. The flu, there's all sorts of different strains of the flu. Asthma. Okay, asthma is a condition where the muscles surrounding the bronchi overreact with certain stimulus, causing them to contract. This makes breathing out more difficult. It makes breathing in more difficult too. The stimuli can be anything like allergies, infections, exercise, particles in the air like smoke or dust, or even emotional like anxiety. So I've struggled with asthma a little bit over my life. When I was young, I think I was about 5 years old actually. I don't even know if you know this story. I was 5 years old and we took a trip to Calgary, go to the mountains. And that was the first time I had a reaction. I had an asthma attack, and so I remember getting taken to the hospital. And it was I could hardly breathe, and it was pretty serious. And that's when my parents kind of found out that I had this I had asthma. So when I was younger, I had to take the puffers. Maybe some of you know about that. You have trouble breathing. When I was older, like as I got into sports and stuff, when my lungs were in way better shape, it didn't bother me at all. Then when I got older and not as active, then it started to affect me a bit more. So diet and exercise and all that sort of stuff can help mitigate that. But in the cold, if I go for even just a short walk in the very, very cold air, I notice I have trouble breathing. So your kind of like your lungs, the passageways in your lungs kind of contract and they kind of overreact, like it says here. So, question? Yep.
Does it ever go away?
Sometimes when young kids have it, they can grow out of it. Like their lungs grow and develop and just become stronger. Sometimes not though. Yeah, sometimes not. Like for me, I always have puffers and I have to take a puffer once in a while. And sometimes it's seasonal, like when the temperature changes or when it starts to get cold out. I noticed that it's, sorry?
Like when it's more like smoke from fires?
Yeah, smoke and dust particles can cause a reaction too. For me, it was a lot of exercise induced when I was younger. So if you start to exercise and then your lungs just kind of like amp up. And it's hard to describe. The way I best describe it, if you're having like an asthma attack or something, or even if you're just having difficulty breathing, it's kind of like you're laying on the floor and like a hippo is sitting on you or something. Like just like you have like 1,000 pounds on your chest. It's like really tough to inhale and to exhale, and it's just it's no fun at all. Well, I think if you just get anxious, your body can react that way too. That doesn't happen to me, but yeah, emotional anxiety. Can you take your headphones out there, please? Yeah, thanks. That's all right. Okay, any other questions there? All right, emphysema. You heard of emphysema before? It's a common condition in the elderly. This is when the diaphragm is not strong enough to fully exhale. As a result, carbon dioxide gradually builds up in the bloodstream. Since carbon dioxide is toxic, it kills off cells and causes damage in the lungs and body. Also, the person will be confused and act as if they have dementia at times. So if your diaphragm is not strong enough to exhale, then just a buildup of CO2. This can obviously be exacerbated, or it can be made worse, by smoking and things like that. It just kind of messes up your lungs' ability to exhale and stuff. But yeah, that's what emphysema is. Pneumonia. Did you know that pneumonia was spelt with a P? Did you guys know that? Pneuma is Greek, I think, for spirit or life or breath, kind of spirit. So pneuma, I believe that's right. Pneumonia. Yeah, it's air, breath kind of thing, I guess. But pneumonia. So pneumonia is when the lungs become inflamed and filled with fluid. This causes a person to have trouble getting enough air. Yeah, pneumonia is kind of like a really, it's like a bad, I mean, it's a bad infection, but it causes fluid to kind of gather in your lungs, and it's really uncomfortable, and it can be fatal for sure. More people died from pneumonia. Now we have medication that gets rid of it pretty quick, so not many people die from pneumonia. Older people have a tough time responding. Sometimes really older people have can pass away from pneumonia. All right, any questions? All right, you guys are doing great. Let's go one more section here, and we'll see. Diagnosis. Okay, so how do we diagnose what's wrong with the respiratory system? Diagnosis of lung diseases and disorders are typically done two different ways: listening and looking. So if you go into the doctor, if you got a really bad cold, or if you think you've got a fever or an infection or something, you go into the doctor, they'll use the stethoscope and listen to how your lungs sound. So they'll look and they'll listen. Sometimes they'll look in your throat and your ears to see if you have any infection. Initial diagnoses are done just by listening to the person breathing. This can reveal if they're having trouble getting breath, if there's rasping sound or gurgling sound or anything out of the ordinary. So if there's like a crackling too, like if you have infection in your lungs, the doctor that listens to you will often say, yeah, I can hear that you have infection there. So it's like almost like a rattle or like a raspy, a jingling almost, it's just crackly, I would say, is the best descriptor for it. So you shouldn't have that kind of sound in your lungs if there's no infection. Here we go. To listen more specifically, a stethoscope is used. We know all about that. With this, you can listen to breathing in a specific part of the lungs, and you can listen to the heart as well. So I'm sure you've all been to the doctor and maybe remember them using the stethoscope on your back and your chest maybe, and they would move that around so they could hear different parts of your lung while you take big breaths, right? So breathe deeply, they say, and they kind of move it around while you're breathing so they can hear different parts of your lungs. All right, it's a bit of a disturbing picture. I'm not sure. She's going to listen to this. I don't know, it looks like a dummy. But anyways, that guy's that's not a real person. Anyways, that's just disturbing picture number one. Okay, respiratory exam. This guy looks almost dead. Better hurry up and help him. Okay. He's quite pale, yes. It's not a color picture either. Okay, most diagnoses will be done by looking though. It's done with an X-ray. So a lot of times you can take an X-ray. X-rays are photos done with X-ray light instead of visible light. As you know, X-ray light can more easily pass through less dense materials. This allows us to get an idea of what is inside a person. Chest X-rays come in 3 types. So how many of you have had an X-ray before on anything, bone or anything? Yeah? If you have a broken bone, or if you have even a sprain or something like that, sometimes they'll check to see if any bones are broken. Yeah?
I have a question. Is there such thing as like an enlarged lung, or like a lung that's too big for a body?
I suppose. Yeah, I don't know what that's called if you have an enlarged lung or. Well, I mean, it's not going to be like your lung is like twice as big as your actual chest, and like there's obviously limiting factors of how big your lung can get, your rib cage being one. But yeah, I don't know what the specific, if it's a disease or what you might be referring to there, but it's possible. But it wouldn't be like your lung is, I don't know where your lung would go inside your rib cage. They would spill out, or I don't know. I don't think that's. Could the lungs be too big and ineffective? Yeah, they could be. You could have it like you could have an enlarged heart or an enlarged brain even, and it's not a good thing. Some of you guys are pretty smart, but I'm talking about, sometimes if you have organs that are too big, they often don't function properly. Okay, what are the types of X-rays? AP. Okay, so an AP X-ray, this means anterior to posterior, anterior, posterior, or front to back. Remember those terms? Anterior is front, posterior is back. This is the kind of X-ray done if the ray goes through you from the front to the back. Since the heart is close, that should be close, to the anterior, this will make the heart maybe look a little larger. think you can really see the heart in this picture. That little circle, I'm not sure what that circle is referring to, but there may be some kind of infection or something in there. That looks a little bit off, but I don't think that's.
The ribs, I think there's a fracture.
Yeah. It doesn't say what is in the circle here. Yeah, it doesn't say what's in the circle. Your heart would be up here. So in the front, your heart would be up here, a little bit center left, I guess. Yep. Okay, so that's an AP X-ray. A PA. This is posterior to anterior, or back to front. Since the X-ray goes from back to front, the heart will appear more like its correct size in the X-ray photo. And yeah, so that would be your spine right here, and maybe pelvis. I'm not sure what this is down here, but that's your spine. That would be the spine of the person. And you can see the ribs, right? These are the back side of the ribs, and then around to the front. So the ribs that come this way are the front ribs. These are the back ribs. Okay. And the third one is a lateral. So lateral is taken from either of the two sides of the body. Lateral. All right, analyzing the X-ray. Okay, you guys are doing great here so far. Let's see. Treatment. Okay, let's do this A, B, C, D, E, F, G. We can get that done for today, and then that'll be good for today. So analyzing the X-ray is done systematically. Shh. Okay, girls, boys, back there. There are many different techniques, but a common one is A, B, C, D, E, F, G sort of method. So what does A stand for? A is air or airways. Check the trachea. It should be straight. Check that no air is under the diaphragm. Okay, so your trachea, straight trachea. If your trachea has been damaged or injured, if it's like not straight, then that's a problem. B, bones and body way. Check that all the ribs are there and not broken or misplaced. Check that the body wall is not collapsed. So airways and bones. A, B, C is cardiac outline. Is the heart less than 50% of the left lung and less than 25% of the right lung? So do we have a enlarged heart? If it's too big, so check the outline of the heart there. Can you make out the outline of the heart chambers? Now, in this diagram, let's see. I'm talking about this one here. That looks like the stomach, I want to say there. It looks like the stomach. Heart. Okay, can you guys see the heart? I can't really see the heart. I'm not sure what they're talking about. I'm not sure if this is the diagram they're referring to. Whoops, wrong button. Yeah, I'm not really seeing what they're seeing here, unless, I don't think that's the heart. That's pretty big to be the heart. Huh. Okay. So I guess this would just be for any X-ray of the heart. You would check to see if the heart chambers are clearly outlined, but it's not in this picture. So D, diaphragm. Is the diaphragm slightly higher on the right side? Are the sharp points at the bottom edges of the diaphragm visible? So the diaphragm should be slightly higher on the right side, I guess. Okay, airways, bones, cardiac outline, diaphragm. Hey, boys. Quit goofing around so much here, boys, please. E, equipment. Is any medical equipment in the incorrect place? Okay, so make sure that, you're taking the X-ray from the correct vantage point. Field, do the lungs reach to the body walls? Are the lungs equal in size? Roughly. One is supposed to be a little larger than the other one, but any obstructions anywhere? So the field of view, equipment field of view. G, great vessels. Can you identify the aorta, superior vena cava, or the inferior vena cava? So the greater or the larger, the most important superior vessels. Can you spot those in the X-ray? And we will pause there for treatments. We'll pick that up tomorrow. Mhm.